Chapter 4, IT Infrastructure, that is the name of the chapter. The learning objectives. At the end of the chapter, you'll be able to do the following. 1. To define IT infrastructure and describe its components. Then you'll be able to identify and describe the stages of IT infrastructure evolution. You'll be able to identify and describe the technology drivers of the IT infrastructure evolution, and to evaluate the challenges of managing IT infrastructure and management solutions. We start by defining IT infrastructure. IT infrastructure can be defined as a set of physical devices and software applications that are required to operate the entire enterprise. So that is the first definition. So in this definition, we are only focusing on the hardware elements and the software elements. But still, an IT infrastructure can be also defined as a set of firm-wide services budgeted by management and comprising of both human and technical capabilities. So in this definition, we look at IT as a service, and the services that the infrastructure includes are: 1. The computing platforms. These ones are used to provide computing services that connect the employees, the customers, the suppliers into a coherent digital environment. So these computing platforms can consist of all kinds of computers, like the mid-range computers, the mainframe computers, the main computers, desktops, laptops, mobile handheld devices, and the remote cloud computing services. So all those are part of the computing platforms. Then we have the telecommunication services. These ones provide data, voice, and video connectivity to employees, customers, or suppliers. Then we have the data management services. These ones are used to store and manage corporate data and provide capabilities for analyzing data. They are also application software services. These ones are for software majorly. Application softwares, I guess we all know what application softwares are. Then we have physical facilities management. These ones involve services that develop and manage physical installations required for computing, telecommunication, or data management services. So if you need to install maybe any hardware that has been purchased, or there is a new database and it has to be installed, those are physical facilities management services. Then we have IT management services. With IT management services, these ones involve planning and developing the infrastructure and coordinating with the different business units for IT services. In other words, ensuring that the IT expenditure is in line with the organizational budget. Those are IT management services. Then we have the IT standards services. Those are for ensuring policies, that is still under IT management, ensuring that policies are in place, and determining which information technology is supposed to be used in the farm. Then there is education, where we provide training for the use of IT services in the organization. Let's say training employees on how to use new technologies or new systems that have been put in place. Then there is also research and development services that provide the farm with research and potential future IT projects and investments. So from this definition, we look at IT as a service, as being composed of different farm-wide services. So it makes it easier for us to understand the value or the business value provided by the IT infrastructure investments. In other words, if you look at what we have talked about, the services that we have talked about, you can note that when investing in IT, you're not simply investing in hardware or software, but in other services as well. So buying the computers and putting them there is not just enough. Those are computing platforms. We have to ensure that other services are in place as well. Then we look at the IT infrastructure evolution. If you look at the IT infrastructure that we have in organizations today, it's some outgrowth of what occurred 50 years ago or even more years. We see that the IT has been changing rapidly in different organizations, and here in this section we are going to be looking at the 5 eras of or the 5 stages in the IT evolution. Each of the stages has its own configuration of computing power. The computing power has been evolving over the stages, and even the technologies that categorize each of the phases have evolved over a period of time for specific purposes. So we start with the electronic accounting machine era, that is 1930 to around 1950. So in that period, if you look at the evolution of computers, there were specialized machines like sorting computer cards. They were majorly used for creating reports, simple reports of maybe accumulated totals and printing reports. Then we move to the second, that is the general purpose mainframe and main computer era, around 1959 up to present. These ones are still in place. So in 1958, IBM introduced its first transition machines, the IBM 1401 and the IBM 7090. So these ones marked the widespread commercial use of mainframe computers. In 1965, the evolution proceeded with less expensive DEC computers or the DEC Min computers, and their prices were quite lower than that of the IBM mainframes. When we talk about the mainframe computers, just like you saw in your computer literacy, these are server machines, very big in size. Then with the mini, they are quite small, quite less expensive, and they are deployed by organizations mostly in the current age. So the DEC computers that were introduced, as we've seen, they were less expensive, and they made it possible for decentralized computing to take place. They were customized to specific needs of individual departments or business units rather than sharing on a single huge mainframe. So with Min computers, unlike the mainframe whereby the entire organization may be running on a single server machine, with them an organization can have multiple Min computers whereby maybe a department, each department can have its own Min server machine, such that there is decentralized computing. Then in the recent years, the Min computers have also evolved into mid-range computers or mid-range servers that are part of the computer networks. Then moving away from that, we go to the personal computer era of 1981 still up to present. These ones are still there. So the PCs actually appeared in the late 70s, where they had different PCs like Xerox, Alto, the MITS Altiria 8800, the Apple 1 and Apple 2, to name but a few. There are many, but they had the only limited distribution to computer enthusiasts. They were not so common because they were still very expensive. Then in 1981, IBM also introduced the IBM PC, and this majorly became the beginning of the PC era. With the PC, as we know, these are personal computers. They can be used by a single individual. So 1981, that marked the beginning of the PC era, and it was majorly first adopted by American businesses. At first, these PCs were using the disk operating system, DOS, which was a text-based command language. You had to know the commands in order to use the machine. And then later on, the Microsoft Windows operating system, called the Wintel PC, was introduced. And as of now, as we talk, most of the machines that we have, especially laptops, our desktop computers, most of them run the Windows operating systems of different versions. Then we go to the client server era. So with the client server era, we have desktop computers or desktop clients, which are personal computers, and they are networked to servers. they have processing work split between the client and the servers. Unlike the personal computer era where each personal computer had to do the work on its own, in this case we have servers on the network, then we have client computers, the personal computers. So the personal computers have some processing power as well as the server computers, and the networks may be multi-tiered or two-tiered. If we say two tiers, the network has two major parts, the server part and the client. Then if it has many tiers or multi-tiered or n-tiered, it has various types of servers like network servers, application servers, web servers, etc. Then we have the enterprise internet computing era. It's 92 still to present. So with the enterprise internet network computing era, we are moving towards to integrating disparate networks and applications using internet standards and enterprise applications. All the applications in an organization, if we are looking at this era, are run on networks. If you look at the organizations where you work or even our USAM, most of the applications can be run over a network, such that different offices, different people can be able to use the application without having to install it on their own machines. Let's say if you look at an example of our e-learning system, you can access from wherever you are. You may not even know where the server where it's installed is, but you can use the application at any time. So here we have a diagram showing the eras, the personal computer era, where we have these computers, personal computers, each working independent of the other. Then we have the client server era, where computers are connected to each other on a network and they can communicate with each other. Then we have the multi-tiered client server era, where we said we can have the client side, this is a client computer, then we have our internet, then we have servers, a number of servers, like we can have the web server, then this one is the application server connecting to the database, this side. So here the client will be making requests for services, and these requests are handled by different levels of servers. So that is all about the evolution of IT infrastructure. Then we move forward and look at the technology drivers of infrastructure evolution. So here we are looking at the factors that are making the IT infrastructure evolve so much. Why is the infrastructure changing so rapidly? Why aren't we still in the mainframe era? Why is the infrastructure evolving so much? That's what we are looking at. So here, the changes in the infrastructure that we've just described have resulted from developments in many areas of computing, like the computer processing power, the memory chips, the storage devices, the telecommunications and networking hardwares and softwares, and other factors. So in this section of the technology drivers of infrastructure evolution, we are going to look at the most important factors or developments that have led to the rapid evolution of the IT infrastructure. So here we start with the Moore's law and the microprocessing power. I think we know what a microprocessor is. With a microprocessor, it's what you call the central processing unit, what we normally know as the central processing unit. So it is the brain of the computer, and it controls how or the speed at which processes or jobs are executed by the computer. So according to Moore's law, it states that computing power doubles every 18 months. 18 months, that is 1.5 years. So every 1.5 years the computing power doubles. If a device, let's say, was manufactured in we are in 2021, in 2019 it will be different from the one manufactured in 2021. Why? Because now the new devices that are being produced in 2021 will be double the computing power of the device that was manufactured in mid 2019, according to Moore's law, because the computing power can be doubled every 18 months. Then the other thing is that the price, according to Moore's law, the price of computing falls every 18 months. So the prices for computing devices keep on reducing. If you bought a phone that you bought in 2019, the same model will be half the price now. If you bought it 200, the same model of phone, if you check on the market, should be half the price, according to this Moore's law. The prices of computing fall every 18 months, meaning devices become cheaper and will have very high computing power as time evolves, meaning the computing power is evolving and the prices are usually falling, so implying that we shall have computers evolving over time. Then the second factor is the law of mass digital storage. Here we are looking at the storage of data. According to this rule or the law, the amount of data being stored each year doubles. The amount of data being stored each year doubles. and the cost of storing digital information is falling at an exponential rate of 100% per year. So the amount of money that an organization will have to pay for storage of data keeps on reducing or falling by 100% per year. So let's say if we are looking at storage of data in 1990 and the amount you spend now for data storage, the prices are reducing very rapidly. So this is the diagram here is showing the falling cost of the chips, because the microchips are reducing in prices. A single microchip can be packed with the multiple transistors, implying that the cost of the storage devices is falling, and the size of the storage devices is falling. Let's say if you look at phones, the storage capacity of the phones that we are having. My first smartphone I think I bought it in 2014, around there. The storage capacity was 1 GB, the hard disk 1 GB, and you had to buy even memory cards, and by then a memory card of 1 GB would be around 40,000. But now just look at the prices. A memory card of maybe 32 GB can be bought at around 30 or 20. Then the phones that we have, except if you have too much unnecessary information, they are enough. You don't even need a memory card. If you have a phone of 32 GB, why would you need a memory card? So the cost of the chips is reducing, and thereby the computing power is also increasing. So here the chart is showing the capacity of hard drives that are growing exponentially. This one is from 80 to 2007. I failed to get 2007 to 2021. I've not got that chart, but as you see, it's increasing. Just like in the example I have given, in 2015 my phone had capacity of 1 GB, and the one I have now is 32 GB, and people have even higher capacity devices. So the growth is increasing annually, meaning that the data that we can store on our devices is also increasing 100% per year. The data I could keep on my phone in 2015 was very little, but what I have now, some people don't even need computers because they have very high capacity hard drives on their phones. Then still we are looking at the cost of storing data, which is reducing exponentially. Previously the cost was very high, but as the time goes on, if we are comparing 1945 and there, where we had a magnetic drive, and now where we are with our different kinds of devices. This one was ending 2006, but now look at it from the perspective of 2021, where we have flash D6 memory cards. Our phones also have their own storage capacities, so the cost of storing data is declining exponentially. Then the third technology driver of infrastructure evolution is defined by Metcalfe's law and the network economics. So with the Metcalfe's law, it states that the value or the power of a network grows exponentially as a function of the number of network members, implying as the number of computers on the network grows, even the value of that network grows. Previously, organizations would be having small networks, but now with the internet, with the growth of the internet, so many devices can be connected to the same network, and as the number of, according to this law, as the number of participants or network members increases, the value or the power of the network grows exponentially, meaning the more the members, the more the value. That's why we can access a lot of information when we are using the wide area network, let's say the internet, which resources we can't access on our local area networks in organizations. So as the network members increase, more people will want to use that network, and hence the value of the network will increase. So that is Metcalfe's law, and it's also driving the infrastructure evolution to take advantage of the value of computer networks. Then the fourth driver is the declining communication costs and the internet. A lot of people around the world are using the internet. They have access to the internet, and over time we have seen that the communications costs fall towards a very small number, almost approaching zero. And the utilization of communication and computing facilities is also exploding as the communication costs drop. Still, I will use an example from mobile telephony. When the phones were coming on board here in Uganda, the mobile phones, around 2000 there, that's when I first saw a phone in my village. But you had to buy the phone. There were those big Ericssons which looked like a brick. You buy the phone, then you had to pay service fee, monthly service fee of around 20,000. Then you pay for airtime subscription. There were like 3 kinds of payments that were made. So each month a person would end up paying like 40. But now, who spends 40,000 for just calls a month? Very few people, maybe those with businesses, because the communication costs are falling towards a very small number. They are almost approaching zero. Look at the costs for data. They are also falling. Now we have bundles of 2,000. Previously the cheapest would be 5,000, but now we have 2,250 UGX. So the costs are reducing, and as the costs are reducing, people are utilizing the communication facilities or the computing facilities more and more. still using the example of mobile telephony, previously in the 2000s you would find maybe 2 people in the whole village having computers, but now even kids, you find a family whereby from the baby the maid has, or each kid has a device. So utilization of the computing facilities is exploding. People are even no longer talking to each other. You just message your husband, but you're sitting in the same house. So that's where technology is taking us, because the communication costs are too low. Then the other technology driver, we have the standards and the network effects. With the technology standards, we mean specifications that establish compatibility of products and their ability to communicate in a network. These days, most of the devices, irrespective of the manufacturer, they can communicate because they are new technology standards that allow computers, irrespective of the make or the manufacturer, to communicate with each other. So those are the technology drivers that drive the evolution of the IT infrastructure. We've looked at the Moore's law and the microprocessing power, where we said the microprocessing power doubles every 18 months. Then we looked at the law of mass digital storage, and we looked at Metcalfe's law and the network economics. We looked at the declining communication costs, and the last one was standards and network effects. So now we are going to another section, and in this section we are going to be looking at the 7 main components of the IT infrastructure. So we have 7 components, or 7 main components of the IT infrastructure, and these include the networking and telecommunication equipment and services, the enterprise and other IT software applications, then the hardware platforms, the consulting services and IT integrators, the operating system platforms, data management and storage, and the internet platforms. So we are going to be looking at them one by one, starting with the computer hardware platforms. I guess we all know what computer hardware is. With this, we are looking at the tangible components of a computer. And when it comes to the computers, we can have client machines, as we saw, our personal computers. The client machines usually will be requesting for resources from server machines. So we have a wide variety of client machines, like our desktop personal computers. You know how a desktop looks like. Our mobile devices, like our laptops, the personal digital assistants, the tablets, the smartphones, all those are mobile computing devices. Then still in this The computing platforms, we have servers of different kinds. The most common ones these days are blade servers, which are ultra-thin computers stored in racks, and they are very, very powerful. You can Google for a photo of a blade server and you see how it looks like. Then we have mainframes. Still, these are servers. These ones are more powerful than the blade servers, and a single mainframe machine may be equivalent to thousands of blade servers. Then we have top chip producers. Those who manufacture computer chips, let's say the microprocessor chips. We have the AMD, I mean those that manufacture the processors. As you know, companies that manufacture the computers are not the ones that manufacture the microchips. So the companies that manufacture the chips, or let's say we use an example of those that manufacture the central processing unit or the microprocessor chips, include AMD, Intel, IBM. You can check if you have a computer and you see the company that manufactured. Most of the cases the label is here on top near the, if you're having data laptop, there will be a label somewhere on the near the keyboard showing the manufacturer, whether it's AMD or Intel. Or you can go to properties if you're using still a laptop or a desktop machine. You go to properties, you click on my computer, go to right click on my computer, then select properties. You'll be able to see the specifications, which will include the kind of microprocessor you're using and its manufacturer. Then the top firms that manufacture the computers, the laptops, the PCs, we have companies like IBM, HP, Dell, Microsystems, etc., Samsung, and then still we have those that are manufacturing the smartphones and tablets, like Apple. Even Apple manufactures the PCs, desktops and the laptops. We have Apple, we have Samsung, Lenovo, and others. Then we have the computer software platforms. We already know what softwares are. So with the softwares, as we know, we have the operating systems, then we have the application softwares. So the operating system platforms, most of the computer devices that we are having, around 95% run Microsoft Windows. It can be XP, NT, 2000, CE, 2007, 2003, 2010, but most of them are using Windows just because Windows is based on a graphical user interface. It's not majorly command line. Then a few of the computers, around 85% of at the server level, most of the server machines are running Linux or Unix, which is inexpensive. It's open source. For Windows, we know it's off shelf, you have to buy, but With the Linux, it's open source and freeware, and it's robust, meaning it's more secure because most of the commands will have to be typed using a command line interface. Unix and Linux are more scalable, more reliable, and less expensive than Windows if you go to the server environment. So they are more suitable on the server environment than Windows operating systems. Then when it comes to smartphones, most of the smartphones and other mobile devices are using Android, which is an open source operating system that was built by Google. So most of the phones that we have are running Android, and some are using Google Chrome's OS, which is lightweight, but the challenge with it is used only if you have internet. If you don't have internet, then you can't be able to use your device. Then others are using the iOS. Those are phones that are manufactured by Apple, like the iPhones and other devices like the Apple iPads and the iPod Touch. Then the enterprise software applications. Those are softwares that are used to run applications. Those are also built using different providers, like we have the SAP and Oracle. Those are the most common, and we also have middleware providers like BEA, and even small-sized businesses in our different countries. Like in Uganda, we have so many small companies that are specializing in software production. Then the third component of the infrastructure is the data management and storage. Organizations usually gather more and more data on customers, on employees, and even on the business itself. Let's say if we are looking at USJA, data is always captured, registering every day, every semester. That is data that is being captured. Employees, every semester they give us load, so all that data is captured. They make the timetable, blah blah. So managing and storing that data is quite challenging. Managing and storing the data that is captured is challenging. So organizations usually have to invest in data management and storage facilities to make data easily accessible and to be able to provide meaningful information to organizations. So data will need to be kept in what we call a database. So we have leading database software providers. We have IBM, which owns a database management system called DB2. Then there is also Oracle. Oracle owns a database management system called Oracle in different versions. There is the Oracle 10G, Oracle 11G, Oracle 12. So there are many versions of Oracle. Then there is also Microsoft, which owns SQL Server. There is Sysbase, which owns the Adaptive Server Enterprise. And then there is MySQL, which is a Linux open source relational database that is now also owned by Oracle. Then there are other database management softwares like MongoDB, MariaDB, and others. So it will depend on the software developer which underlying database management system is used on the application. Then when it comes to physical data storage, it is currently dominated by the EMC Corporation. If you have large scale systems and you want someone to host for you, don't want to have your own database application developed at the organization, there are some physical data storage companies that can host that data for you on their networks. Then we have another component, networking stroke telecommunication platforms. So here we look at majorly the telecommunication services. We look at the telecommunication services. We look at cables for configuring networks. We look at telephone companies, their charges for voice and line and internet access. All those things are under the telecommunication services. Then we also look at the networks, where we look at the network operating systems. There are a number of network operating systems that are being used, like the Windows Server, which is most predominant in our local area networks. We have Linux and Unix, Novell, and those are for large enterprise-wide networks. Then they are also leading providers of telecommunication devices, those who are providing us with the routers, with switches to run on our networks, also provide network cables. So those are the network providers that we are talking about, and the most common ones are Cisco, we have Juniper Networks, we have A&T, we have Lucent and Nortel. There is also D-Link. If you check the most common network devices, let's say if you have a network switch in your office or somewhere in the school, you can check our wireless routers at USJM. When we return, you'll see that most of them are either Cisco or D-Link. Those are the most common providers. Then we have internet platforms. With internet platforms, we look at everything to do with the internet. So the platforms overlap so many things. They overlap with the networking infrastructure, the hardware, the software platforms. So all those are part of the internet platforms. So internet platforms consist of all the hardware, the software and management services to support a company's website or a company's intranets and extranets. So it also includes web hosting services. With web hosting, we mean a service that maintains a web server or a series of servers. For a document to be accessed over the internet, that document has to be uploaded or hosted on a web server, a special computer called a web server. So these web hosting services are at times provided by companies, or an organization can choose to buy its own web server and host its own applications. Then internet hardware server markets include Dell, HP, Compaq and IBM. Then we also have websites on the internet. We shall be accessing information that is organized into web pages, and a collection of web pages belonging to a particular domain or the same domain is what we call a website. And we have different suites or tools for developing web pages. We have Microsoft, it has its front page. There is IBM, which provides WebSphere. There is Oracle, which owns Java now. It was previously Sun, but now it is Oracle. It was taken over by Oracle. Then there is independent software developers who use things like Macromedia, Adobe Real Media. Then there are also internet services whereby you can just customize a few templates and come up with a website. For instance, Google Sites, you can come up with a website using that. There is Wix.com and other sites. Then we have consulting and system integration services. These ones are for large firms that don't have resources for full range of support for new complex infrastructures. So if your firm doesn't have the money or the manpower to manage your IT infrastructure, you may not have enough resources, so you can hire a consulting firm to help you with your IT needs. Maybe you need a software, you don't have a team, an IT team to configure it for you, or it may be expensive to hire your own team. So you may consult a firm. There are IT firms that are specializing in this. So that is consulting. Then with software integration, it's all about ensuring that the new infrastructure works with the legacy systems or the old systems. Let's say you're buying new servers or you're introducing new software. So with the integration, you're integrating the new system, let's say new software or new hardware, into the existing systems like older TPSs. So that is all about the components of the IT infrastructure. Then our last topic for today is about management issues. So we know that creating and managing a coherent IT infrastructure will raise multiple challenges, like dealing with platforms and technology change, dealing with the cloud, mobile computing. So there will be challenges in dealing with the technology change. There will be challenges in managing and governance of the new infrastructure, and also challenges in making decisions about wise investments. So here we are looking at management issues that you're going to face as managers in managing IT infrastructure. So the first one is the changing sources of software. As we know, there are many sources of software. You can get software packages and suites. Those are existing, already developed, and you bring them on board, customized, they meet the needs of the organization. Or the source can be an application service provider. An application service provider, or the ASP, these are businesses that deliver and manage applications and computer services from remote computer centers to multiple users using the internet and private networks. So the company may have or may hire an application service provider. They already have their applications, but they can manage them remotely. You're using them, but they are managing them. Or you can outsource and get the software developed to meet your own needs. It can be domestic, where you hire a company from within your country, or offshore, where you get a company to develop for you from outside. So as a manager, you should be very keen on deciding which source of the software best suits the problem at hand. Because let's say if you get a package or a suite, it may not meet the needs. And ASP, there are a lot of challenges with security. Outsourcing may be expensive. So deciding which one to choose, which source to choose, may be quite a challenge to you as a business manager. Then the other challenge or issue that you face is dealing with scalability and change. Firms will usually grow. Every business is meant to grow. And as the business grows, its IT needs to be flexible and scalable. So as the business grows, the IT should grow with the business. It should not be how can I call it? The IT should not be dormant. So as the organization grows, the information needs of the organization will grow. So the IT needs should be flexible, such that whenever there is a new change that needs to be brought on board, you can always alter maybe the software or easily add a new hardware to support the new needs. Then the other issue is management and governance. Deciding who controls the IT infrastructure is a challenge. Who controls? You are the business manager, but who controls the IT infrastructure? Who budgets for it? Those issues will always arrive, because remember, the IT budget is spread. All business units will have their own IT needs. So deciding who controls the infrastructure, who controls the budget, will be a challenge. Is it centralized, that maybe central management budgets, or is the budget decentralized to the individual departments? How are the costs allocated between divisions and departments? All those decisions will have to be made by you, the manager. Then making wise infrastructure investments is also an issue that you're going to face. You may bring an investment on board and it fails to work. So deciding the amount to spend on IT is a complex question that you will always have to reflect on as a manager. If you rent or buy or outsource, what would be the best option? Because if with renting a software, let's say, or a hardware, you keep on paying, but buying, you may need to put in more at the start. So you will have to figure it out as a manager. Then there is a total cost of ownership of technology, or the TCO, total cost of ownership. So the TCO model is used to analyze direct and indirect costs of systems. In most of the cases, the hardware, the software usually accounts to 20% of the total cost of ownership. But there are other costs. It's not like when you have the hardware and the software, now you have invested, that spending stops there. No, there are other costs like installation. Who is going to install? You have to pay that person. Costs of training the people, costs of support and maintenance, because the systems may fail from time to time, so you need someone to maintain them. The infrastructure supporting the hardware, downtime, space and energy that is spent, all those costs have to be accounted for. So the total cost can be reduced through greater centralization, whereby you have a central budget and you standardize the hardware. Let's say for you yourself, for us, we are using Dell. All our machines in this organization have to be Dell. Or for networks, all our devices are Cisco or D-Link. So it makes maintenance easier because you'll be having the same standard hardware and software resources. You see, maybe for us, we are using only Windows. For all our computers, Windows 10. For the servers, Linux. So if you standardize, then the cost of ownership may be lower because you'll be reducing on the installation costs, training costs, and the maintenance costs. So that is it for today. We've looked at a number of things to do with the IT infrastructure. We started by defining what IT infrastructure is. We looked at the technology drivers of IT infrastructure. Then we looked at the components of the IT infrastructure and the management issues that you will face as managers in managing the IT infrastructure. So I wish you all the best. If you want more details about this chapter, you read chapter 5 of the reference book. Thank you.